This is the solution video for section 5.2, problem number 5. A particle moves along the x-axis so that at time t, its position is given by x of t equals sine of pi t squared for t between -1 and 1. All right, A says find the velocity at time t. So very simple. If x of t, if position is this, then all we're looking for is v of t, right? So the velocity at time t, so v of t, right? Not a specific velocity, but just the general velocity equation. All right, so the derivative of the sine of pi t squared. All right, so derivative of sine is cosine of pi t squared times, now don't forget about the chain rule, derivative of pi t squared. Remember, pi is a constant, so pi times the derivative of t squared, so 2t. So 2 pi t. All right, and so that's v of t. Find acceleration. All right, acceleration. All right, so a of t, very simple, is just the derivative of this. But now remember, the acceleration needs to use the product rule, right? So I have cosine of pi t squared times the derivative of 2 pi t. Remember, 2 pi is a constant, so 2 pi, plus 2 pi t times the derivative of the cosine of pi t squared. So remember, derivative of cosine is negative sine, so I'm going to put a negative 2 pi t in front. Sine of pi t squared times the derivative of pi t squared, which is 2 pi t. All right, so that is our function. Now, we could simplify it a little bit. Sorry that I'm going to kind of run out of room here, but we could simplify it a little bit to be 2 pi times cosine of pi t squared, and then minus. Now, I've got a 2 pi t here and a 2 pi t here, so 4 pi squared t squared sine of pi t squared. All right, so that would be the kind of the simplified version of the acceleration. All right, but then it says, for what values of t does the particle change direction? All right, so we don't need acceleration for that question. So now we're just going to go back to the velocity. When is velocity 0? That's the first question. And then we need to do a sign analysis to figure out when it changes direction. All right, so velocity equals 0. Cosine of pi t squared times 2 pi t. So we have two things multiplied together to equal 0. So either 2 pi t equals 0 or cosine of pi t squared equals 0. All right, so 2 pi t equals 0. So I divide by 2 pi, I get that t equals 0, right? That's easy enough. All right, but then I have cosine of pi t squared equals 0. All right, so now unit circle. When does cosine equal 0? All right, so remember, cosine is equal to 0 at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on. So pi over 2 plus pi n for any integer n. All right, but remember, that's what pi t squared is equal to. So now we're going to divide by pi. So if I do that, I get that t squared is equal to pi over 2 divided by pi, so that's 1/2, plus divided by pi, so that would just be n, right? And so then I'm going to square root, and I get that t is equal to the square root, and remember, plus or minus the square root of 1/2 plus n, right? So n is any constant. All right. So, sorry, not any constant, any integer. All right. So what does that mean? Well, if n is 1, I have 1/2 plus 1, right? So that would be 3/2. The square root of 3/2 is larger than 1, right? And so that's out. So really just plus or minus square root of 1/2, right? So square root of 1/2, which you could rewrite as 1 over root 2, or you could say that that is plus or minus root 2 over 2. Right? And so now, when does the object change direction? And for D, it's when is the particle moving to the left? Well, they're both going to be associated with the sign analysis. So I'm going to do a sign analysis. And remember, our endpoint is -1. Our other endpoint is +1. We have 0 in the middle. And then we have negative root 2 over 2 and positive root 2 over 2. All right, so I have two factors, 2 pi t and the cosine of pi t squared. All right, so now I'm going to put a 0 above 0 for 2 pi t, and I'm going to put a 0 above negative root 2 over 2 and positive root 2 over 2. All right, and so now I have these intervals of interest. All right, so now pick a number to the right, or sorry, to the left of 0. So 2 pi times a negative number is negative. 2 pi times a positive number is positive. That's easy enough. All right, now, this is actually pretty easy because we're just going to be plugging in 0 and 1 and negative 1. All right, so pick a number to the left of negative root 2 over 2. How about negative 1? Cosine of pi times negative 1 squared. Negative 1 squared is positive 1, so cosine of pi. What's the cosine of pi? That's negative, right? Negative 1. All right, now we plug in 0. All right, so cosine of pi times 0 squared. All right, so 0 squared is, of course, 0 times pi is 0. So the cosine of 0 is positive 1. So we put a positive here. All right, on the right, we plug in 1. Cosine of pi times 1 squared. So 1 squared is 1 times pi is pi. So cosine of pi is negative. All right, so now carry down the signs. Negative times negative is positive. Negative times positive is negative. Positive times positive is positive. And positive times negative is negative. So when does the object change direction? Change direction is when the sign of velocity changes, right? So velocity changes sign at negative root 2 over 2, 0, and positive root 2 over 2. So the answer for C is t equals negative root 2 over 2, 0, and positive root 2 over 2. And then it says, when is the object moving to the left? And so moving to the left would be when velocity is negative. So negative root 2 over 2, comma 0, and root 2 over 2, comma 1. All right, so that is problem number 5.